Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the VCAR 2022 paper for exam 2 for maths methods. I've had my students still suggesting me to do the extended response. And yeah, so let's do this. By the way, I've not touched this paper. It's the first time that I'm doing this. It's because I try to do the questions without knowing the answers because I want to experience how it feels to be in the exam that day. So yeah, I can make some mistakes, and if I do make mistakes, please make sure to comment down below and I'll try to fix them. Let's do this. Okay, question 1. The diagram below shows part of the graph of y equals f of x, where f of x is x squared over 12. Okay, state the equation of the axis of symmetry of the graph of f. Okay, so here's a graph of f, and the axis of symmetry is pretty much at x equals 0. Yep, so we can say x equals 0. And yeah, that was 1 mark quick. Okay. State the derivative of f with the respect of x. So it's just 1 mark, so I'm just gonna use my calculator. So f dash of x pretty much is equal to, so first I'm going to define the function. So define f of x as, define f of x as x squared over 12. So x squared over 12, and we want to find the derivative, which is, x over 6. X over 6. The tangent to f at point M has a gradient of -2. So the tangent to f at point M, so we can see point M's over here. So over here, has a gradient of -2. Find the equation to the tangent. Okay, so it's 2 marks. So what I'm going to say is the f. So I'm going to pretty much say solve f dash of x equals -2 for x. And we can get the value for x. So using our calculator, we can say solve answer equals to -2 comma x, which we get x equals -12. So x equals -12, and using that, we can pretty much use go in menu, go in calculus, go in tangent line, because we want to find the tangent line. And we're going to write f of x, comma x, and what value? -12, at point -12, and it gives it straight away. So your answer for that is y equals -2x minus 12. Okay, and that should give you 2 marks. Okay, the diagram below shows the part of the graph of y equals f of x to the tangent to f. So, okay, this is your tangent to f at point M. This is the tangent. And the line perpendicular to the tangent, so your normal line, which is this one over here. Just pass it over here. Find the equation. So it says find the equation of the line perpendicular to the tangent. Yep, passing through point M. So we just want to find the equation of the normal. To do that, it's very easy. So we know it still occurs at the same point. So still at x equals -12. So just using our cat again, menu, calculus, and we go normal line, f of x, comma x, comma -12. We get x over 2, so y equals x over 2 plus 18. That's it. That should give you the mark. Next question. The line perpendicular to the tangent at M, which is the normal, also cuts f at point N. Okay, so it cuts over here, as shown in the diagram above. Find the area enclosed by the line and the curve y equals f of x. So, so enclosed by the line and y. Okay, so to do that, so what we're trying to do is we're trying to calculate this area over here, this area. And to do that, what we need the 2 points. So this point over here, and we already know that x is -12 here. So to do that, we can just try to find the intersection between the normal line. So the normal line's x over 2 plus 18. We want to equate it to the graph of f of x and solve for x. So your x values here, so I'm just going to use my calculator, and we're going to say solve this over here, put it over here, equals f of x, comma, x. Okay, so we get x equals negative 12, which we already have, and x equals 18. So x equals 18, so it's right over here. So now what we can do is to find the area. So area is the integral from negative 12 to 18 of the upper function, which is your, this one over here, y equals x over 2 plus 18, your normal line. So I'm just going to put it over here. So it is x over 2, so x over 2 plus 18 minus your lower function, which is your f of x, which we will just write f of x dx. Therefore your area, so I'm going to do on my calculator. Alright, from negative 12 to 18, okay, this function, put it over here, minus f of x, comma x. So 375. So 375 units squared. Okay, that should give you 2 marks. Question E. Another parabola is defined by the rule g of x, so x squared over 4a, where a is greater than 0. So a tangent to g, okay, and the line perpendicular to the tangent x minus b, where b is greater than 0, is, okay, so we have the graph of g of x, and we have a tangent and at point, so we have this tangent at this point, negative b, at this point, and there is a normal line also that passes. So it's the same case as this, but we don't know the value of a. Okay, so what can we do here? It says find the value of b in terms of a such that the shaded area is a minimum. Okay, and it's 4 marks. So what I'm first going to do is I'm going to calculate the area. So to calculate the area is what I'm going to do is I need to find the point of intersection. So I don't know this value over here, which I'm going to try to find out, but I know that one here is x equals minus b. So what I'm going to do is calculate, so I'm going to define g of x. So first, define g of x. So define g of x as x squared, so x squared, 4a times a squared. Okay, so that's that. And what we want to do is we want to calculate the normal line. So this line here, we want to calculate the equation of this normal line over here. Well, we know it's at x equals minus b, so we're just going to use menu, calculus, normal line of g of x, comma x at negative b. That gives us this big equation. So we can say that, okay, let's call it y1. So this equation here, let me just call it y1. So your normal y1. So y1 is equal to 2a squared x over, over b plus 8a 4 plus b squared over 4a squared. And to calculate the, again, so what we can do is we can calculate the intersection, the value, we can equate them to find the value of the intersection to get this value over here. So we can say we want to solve for y1 equals g of x for x. So by doing that in our calculator, okay, so we're going to say solve, answer equals g of x, comma x. Okay, so x minus b, which is this over here, and so this value over here is 8 to the power 4 plus b squared over b. And we're just going to write it over here. So x is 8a to the power 4 plus b squared over b. We want to make sure we do so many working out because we have 4 marks we need to obtain. Okay, so to find the area, it's very easy. So the area is the integral from negative b to this over here, which is negative b to, I am just going to pretty much bring this up here. I'm just going to copy this too. Okay, and make it less small. I'm going to put it over here. And so from there to there of y1 minus g of x dx. Okay, no. So I just want to know something here. So am I doing with the respect of, yep, g of x. Okay, hope that's right. So I'm going to do it on a calculator. So we're saying the integral from minus b to this value of this normal line over here, put over here, minus g of x, comma x. Okay, so we get this disgusting function. Okay, very big. Alright, so what I'm going to do, I have too much working out, so I'm just going to move this and make it less. Oops. I'm going to make this smaller. Okay, I'm just going to put it over here. And I'm going to take this and put it and make it smaller over here. Okay, so that equals to 64a to the power 12 plus 48 a to the power of a b squared plus 12a to the power of 4 b power 4 plus b squared all over 3a squared b to the power of 3. So okay, that's our area. That's our equation of the area. So what I can use that now to find the minimum. So what I can do is, because I want to find the value of b. So I want to find the value of b. So think of b as our x. So what we want to do, and a as a constant because we want it in terms of a. So what we want to do is we want to derive. So a with the respect of a of a. So this equation a equals so we want to derive this, so using our calculator with the respect of a, this whole function, enter, and we get this, and we want to let it equal to 0, and we want to solve for a. We want to solve for b equals what? Oh, well, we don't actually we can just do a quicker method. We can just actually find the maximum by just going menu, calculus, function maximum of this, the area, copy that, paste it over here, comma, so we want to find the value of b, where b is, that's it, so where b is greater than, so we just want to put over here, where b is greater than 0, blah, 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 control enter, okay, yuck, okay, what has happened here? What about if I just say this, okay, b equals minus 2a, have I done anything wrong here? 64, okay, say, we take this, there's something wrong with this, okay, wait, what have I done? I need to copy this, I'm not too sure, so I need to copy this, and I need to find the function maximum, so calculus, function, minimum, oh my god, function minimum, so, okay, that explains, okay, function minimum of the function in terms of b, okay, we get b equals 2a, 2a squared, Is that right? B equals 2a squared? Or was it b equals negative 2a and you find the other answer? We got b equals negative. So, but, okay, this was the maximum. We want the minimum, so it should be b equals 2a. Hope that's right. So find the value of b in terms of a such that the shaded area is a minimum. I think it is. Not too sure. Okay, I need to check it after. Okay, find the value of b in terms of such that the minimum. So dA over a equals 0. Okay, hope that's right. Well, let's move on to the next question. Question 2. On a remote island, there are only 2 species of animals, foxes, rabbits. The foxes are predators and the rabbits are their prey. The populations of foxes and rabbits increase and decrease in periodic pattern, with the period of both population being the same as shown in the graph below. Okay. For all t is greater than 0, where t is measured in weeks, one point of minimum fox population, so this point over here, and 1 point of the maximum of fox population, which is here, is also shown on the graph. The graph has been drawn to scale. Okay, to scale. Perfect. So, now knowing that, it says the population of rabbits can be modeled by the rule of this. So, I'm just going to delete this and just define the function straight away. So, define r on t equals 1/700 sine pi times t, at plus, okay, perfect. So we've defined that. So the initial population of rabbits is what? Okay, the way I'm going to do this is, okay, this is the fox. So this line is the fox. So I'm just going to do this. I'm going to sketch over it so I can see that. Okay, it's such an ugly sketch, but it does the job, which is f on t for the foxes. And this is for the rabbits. Alright. Okay. And that's for rabbits. So we want the initial of the rabbits. So, okay, we want for the rabbits, so the initial population. The initial population is over here, which is 2,500. So your answer here is 2,000. So just let me... Yep, 2,500. That's what Mark should. State the minimum and maximum populations of a rabbit. Okay, so the maximum is over here, which is not too sure. Okay, so we can check the maximum by what we can do is normally we can. So this is the rabbit, yeah. So we can add this to this. So if we add for the max, so max is 2,500 plus 1/7, which equals 3,200. And your minimum is 2,500 minus 1/700, which is 3,800. Okay, that's it for that one. Set the number of weeks between the maximum populations of rabbits. Okay, so for rabbits, so this is the maximum point, and this is also a maximum point. So if I'm going to draw down, here is 40, and here is 200. So it says state the number of weeks between the maximum. Okay, so the difference is 200 minus 40, which is 160 weeks. Okay. Let's move on to the next question. The population of foxes, so foxes can be modeled by f on t, which is this value over here. Show that a equals 900 and b equals pi over 80. Well, what we can do is we can say that the middle value, so, okay, to do this, what I'm going to do is, okay, I'm just going to rub this out and just copy the graph. Okay, let me just rub this all out. Okay, let me just rub these all out, these things over here, We don't need those. Okay. I'm just going to copy this, take a screenshot of it, and do it over here. Okay, so let's come down here, paste it. Okay, so we have this over here. So this is for foxes. So for the fox, which is the orange graph, to calculate the value of A, so the amplitude, it's pretty much the middle value. So this is your maximum and this is your minimum. It would be between them, so in the middle of them. So it would be somewhere in between. So what we can do is we can get the the y values over here. So 2,500 plus 700 and divided by 2 to get some value over here, which I'm not too sure, which would give us the A value. So I'm going to do that over here. So that will mean, so for the A value, A equals, okay, 2,500 plus 700 all over 2. So all over 2, which will give us, so using my CAS, okay, 100 plus 700 divided by 2 gives us 1,600. So 1,600. Okay, wait. What? Wait, have I done anything wrong here? Wait. This is that value and this is that value. I've added them together. Yeah. And I divided them by 2. Which gives me 1,600. What? Wait. What's happened here? Wait. Have I done anything wrong? Well, A value should equal to 900. So, just let me have a look. Okay. So, okay, for fox, is that okay? And it should be in between. So why is it? Okay. Okay, let's try another way. So what we can do, there's many ways we can approach this question. So what I'm going to do over here is just change that up. So I know for a fact that also that when we have 2, so normally to get the maximum number, what we do is we add this 1,600 plus the A equals, well, our maximum is 2,500 here. 2,500. A is equal to 2,500 minus 1,600. So A is actually equal to 900. Okay, here we got A equals 900. So, okay. I don't know why I did not get the other one right. Did I do something wrong? Let me just put that over here. So that's that. For B, it's pretty much the period. Because if we pretty much expand that over here, so it will be B on T, which is your period. So the difference between the peaks. So let's look at this peak, which is 100. And here, which I'm not to wait, is this 600? So I think, yeah. So it's okay over here. So we can say, so to get the period, so period is equal to 260 minus 100, which is equal to 160. And I know we know normally the formula is 160 over 2 pi n. So 2 pi b, not n for this here. So 2 pi b, which is pi on 80. Okay, wow. That's it for this one. So we've shown that they are that. I'm just so confused. Yeah, it's 2,500 divided by 2. I just want to double check how I got the other one wrong. Divided by 2, which was that. Okay, I see what I did wrong. Okay, let's go to question C. Find the maximum combined population. Okay, so we want to find the maximum combined populations of foxes and rabbits. Give your answer correct to the nearest whole number. All right. To do that, what we're gonna do is we want to now define f on t, so the foxes. So we'll define f of t is equals so it will be 900 sine pi on 80 times t minus 60 plus 1,600. So we got that. So to find this, so what we're going to do first is we're going to add both the population of the rabbit, so R on t, so the rabbit, plus f on t, the foxes, and we get this function over here. So we want to find the maximum combined population. So to find the maximum is, I pretty much just take this, copy it, and go on graphs, and just paste it over here. Well, let's change t to x to graph them. Okay, go on menu, go on this, and go zoom fit. Okay, so we get this, and we're just gonna a little bit zoom out more. Okay, zoom out. Okay, more. We have to actually zoom out very much more here. Okay, sorry, perfect. So what we get here is the maximum number we get over here is 53.7, but we also have more. So find the maximum combined. Find the maximum combined population. Give your answers to the nearest whole number. Okay, we got this. Well, is there like a domain restriction from? Okay, we do have a domain restriction, which is because if we look at this graph, it's from till 320. So we want to say from. Okay, if we come over here, we can say that 0. 0 less x value to so 320. Okay, now we only get two maximum picks, but which one would they be? Let's just have a look. So also maximum over here, we get 2. Yeah, so because we have 2, wait, can we tell them? Find the maximum combined of foxes rabbit, correct to the nearest whole number. What can we do? Well, we've done that. Let me just go in here and go on calculus, function maximum, put this function over here. T, so T is the value that, T is the value what we want from 0 to 320, which gives us T equals, okay, so it already gave, okay, so this is your answer. Yeah, so using the F max is better, because yeah, this means this is your minimum for some reason. Yeah, this is your answer. So T, so to a whole number is 214. That's your maximum number. What is the number of weeks between the periods of when the combined population of foxes rabbit is a maximum? Number of weeks, okay. Well, we have the graph, and it's just the difference between these two. It's just the difference between these two over here, which is, so 214, so we can say 214 minus this value over here, which we can pretty much copy. Oh, we don't even need to copy it. Wait, 214, let me just, okay, so take this over here, minus, copy over here, and so we get 1, so what is the number between these two? Okay, so it's just 160. I hope that's right. So the population of foxes is better modeled by the transformation of y. Okay, we need to be careful. So the population of foxes is modeled by the transformation of y under q. Okay, so originally the function is sine t, but we transform it using q, so this over here, to make an equation. Okay, find the average population, so average, so between 2 points. So find the average population during the first 300 weeks for the combined population of foxes and rabbits, where the population of foxes is modeled by the transformation of y equals sine t under the transfer. Okay, and it's 4 marks. Let's just start by. So we know that y equals sine t. And it goes through this transformation over here. This transformation over here, which expands to t dash equals 90 pi t plus 60. By the way, this question is not in the new study design, which is from 2000 and so which is that? So we have from 2023, I believe, to 2027. So yeah, you don't need to know how to do this question, but it's very good to know what transformations are. So we get t dash this, and we also know that y dash is 900y plus 1600. We solve for t and y, so for this one will be t is equal to t dash minus 60, and it's all multiplied by pi or 90. And we get here y dash, okay, so we get y is minus this over 900. And so we shove all of these over here into this function over here. So it will mean that, okay, what have I done here? So, I'm supposed to write y dash here. Okay, so we're saying that y dash minus 16 over 900. I'm going to make sure to put that over here. Okay. Yep. Equals sine. Your value of t is, so pi t dash minus 60 all over 90. Okay. Now I'm going to, solve for this for y dash. We're going to try to solve for y dash here. So what I'm going to do is use my calculator. So I'm just going to go on solve for, so let's call it y minus 16,900 equals sine pi, so we can say pi times t minus 60 over 90. Okay, comma y. Okay, so we get this. This is our equation. And okay, so we just rub this off, and this is now your new Fox equation. So f of t is 1/6 this minus 900 sine pi t over 90 plus pi on 3. Okay, I'm just going to take this. And you know why I'm showing all this working out? It's because it's a 4 marker. You need to show as much as working out you can. You can't just use a calculator for this. So now we know that equation of the fox. Now we just have to add them. So we want to add the population of the, so this is the fox. We just need to add, so the total population. So let's say t of t is f on t plus r on t. So rabbit and the fox, which is equal to, so this equation over here plus r on t. We get this over here. I'm just going to write it. So 1700 sine pi t over 80 minus 900 sine pi t over 30 plus pi on 3 plus 4,100. I'm just going to make this smaller, and we are pretty much nearly done. Now all we need to do here, all we need to do now is calculate the average. Okay, you need to understand something here. When they say average, we actually are here. They're trying to trick you. But you're probably thinking, oh, average means using the rate of change, the average rate of change. No, the average population. When they actually say average rate of change, that's when you have to use the formula, you know. But here they're just saying the average population, which is normally the average value. So we can say average value. So your average value is pretty much integral, not integral, so 1, 2. So where are we? So wait. The average population during the first 300 weeks. 300 weeks. So 300 minus 0, which is just 300, from 0 to 300 of the function t on t with respect on t, which should give you the answer. I'm just going to do this on the calculator. I'm just going to zoom this a little bit less. So average value is, average value is equal to, okay, I'm going to integrate from, okay, before that, I'm just going to write 300, 0 to 300, this whole equation, put it in here, come here, and write t, and we get 4,142, wait, is it to the nearest whole number? So yeah, we get your average value 4142. That's your answer. I'm just gonna highlight that. Yeah, that was a 4 marker. Wow, that's took a very long time, but yeah, I hope that's right. Over a long period of time, it is found that the increase and decrease in the population of rabbits gets smaller and smaller. The population of rabbits over a long period of time can be modeled by this equation. For all t, okay, so we got a new equation. So I'm just gonna delete this whole thing. Can I? Wait, should I? Okay, I'm not gonna delete it. Maybe we need something. So I'm just gonna define a new function. So define this function, which is s on t equals so it is 1/700 times e to the power of negative 0.003 t times sine pi times t 80 plus 2,500. Okay, so we get this, and we want to first find the average rate of change. Okay, rate of change between the first 2 times when the population of the rabbits is at its maximum. Okay, so what I'm gonna do is at maximum, find the rate of change between the first 2 points when the population of rabbits is at maximum. Okay, to do that, I'm just gonna actually graph this. So first, I'm just going to take this and let all these values, so let t equal x, and copy and paste that on the graph. So I'm going to make a new graphing, paste it over here, and go on Windows, zoom fit, and I'm going to just zoom out. Okay, zoom out, zoom out, zoom out. Okay, we got 2 maximum peaks here. So we just want to find the average rate of change for these 2. I think so. So maximum, this point over here, maximum also at this 2 point here. So let's do that. So we're saying to find the average rate of change, maximum peaks, so it's close to 200. So I'm just going to get like the exact number. To get the exact number, what we're going to do is go on calculus, maximum of the equation, so this equation, comma t, comma, from 0 to 200. Okay, it still gives us 1. Why does it give us 1? We just want this one too. So what? Okay, okay, so what I'm going to do is I'm just going to use that. Okay, let's say f from 198 minus, sorry, it's s on t here. So it's s 198 minus S 38.1 all over 198. So this value over here, Control C this over here, minus this value over here. Is that right? Is that right? I'm just going with 38, 30. Okay, which is corrected one decimal place. You're looking at, yeah, 1,000. Oh no, sorry. What am I doing? Yeah, so 198 minus 38.1 equals what? So what I'm going to do for that is I'm going to divide S 198 minus S 38.1 and take this value and put it over here. Enter. And we get this number over here. To one decimal place, it's negative 3.6. So negative 3.6. Is that right? I think so, yeah. Negative 3.6. Next question. Find a time where t is greater than 40 in weeks where the rate of change... Okay, so t is greater than 40. When the rate of change of the rabbit population is the greatest positive value. So rate of change means S dash on t. So we want S dash on t of the rabbit population, okay, to be at its greatest, so maximum positive value, so positive value. All right, okay. So find when the t is greatest maximum. Okay, so what I'm going to do here is first find S dash on t, because it's 2 marks, we have to show some working out. So for that, I need to go on calculus. Okay, so derivative of the respective t of S t, and we get this ugly function. Yuck. Okay. Okay, wait, find the greatest. I'm not going to type this in. I think it's quite useless to type that in. So what I'm thinking of, set S dash on t, where we want to let it equal to 0, and we want to solve. So, algebra solve this. Okay, there's 2 solves here. So this over here, we want to let it equal to 0, comma t, where t is greater than 0. But we must restrict t from somewhere else. I mean, it's like a periodic table. It goes to infinity at its finest. So t is greater than 0. T is greater than 40. Yeah, so we get a general solution. So how can we do this? The greatest when the rate of change of the population is this. Okay, what I'm going to do is I'm going to copy this. I'm going to copy this equation, the derivative of it. Wait, I'm going to copy that. I'm going to let every t value equal x, and I'm going to copy that and go on the graph and paste that. And I'm going to go zoom fit. Zoom that, fit. Okay, so we get this. And just let it be analyze. Zoom out more. Okay, so if we zoom out more. Okay, now it's better. Now it looks much more. Okay, what can we see here? Oh, so can we see how it's getting smaller and smaller? So for the time where t is greater than 40, so where is that? So if we just put a relation here, where x, well, for this value, x is, let's say 40. So we want it, 40, why did I write 30, 40? So we want it to be, okay, so this is the point only. This is the actual point. When the rate of change of the rate is greatest positive value, so it should be that point. So maximum, maximum of this graph, which is this value over here. So give your answer correct to the nearest whole number. It should be t, so t equals 1,5, but it's saying give it to the nearest whole number. This is where they're trying to trick me over here. Nearest whole number. So the answer may be wrong because 156. Let's go to the next pick over here. because they're saying nearest whole number, but this is already a whole number, so they must mean that I got it wrong here. So maximum, maybe this is the point. Finding two is going when the rate of change of the rabbit is greatest in the positive value. Well, here's positive. Here's also positive. So what? Okay, I'm just gonna let it t equals 156. I hope it's right. Find the t1d when the rate of change is greatest. Okay, positive value, give your answer to the nearest whole number. Not very sure, but okay. Okay. Okay, to act like I've done, to at least to get 1 mark, if this is wrong, to get 1 mark, I'm just going to say we've solved t, and we got, analyze guys, minimum, we got 76.1, t is also 156, that's it. I think that should give you the point. Only 1 mark, but I'm hoping that's right, so it should give us 2. Over time, the rabbit population approaches a particular value. Okay, to do this one, it's very common. You'll see this in exam. All you can do is go on your calculator. Go back to the functions. And, okay, what you want to do is you want to use a limit. So we want to say limit as t, because t is our variable, t approaches infinity. So t approaches infinity of the function, which in this case is s on t. That gives us 2,500. So your answer here is 2,500. That's how you do this one. So what it means is pretty much, what is a limit? A limit is, example, if you look at the graph, I think if I just look at that graph, if you look at this graph, I just need to zoom out more. All right, so pointer. Okay, take these out of my way. Can we see how the number is getting much? It gets to 0, it looks like, but set a value. Okay, I see. So I'll just explain what it means. So this function over here, which is s on t, this is not s on t, is it? No, it's not. I don't think it's s on t. So let me just take the function s on t. S on t, and we want to take this function, and I'm going to show how the actual graph looks like. So this, if I can take this and make all the variables t equals x, and copy this and put it on a graph, a new one. Hope it looks better. Okay, and let's just Windows zoom out. Oh, no, Windows fit, actually, much better. And okay, here, let's just have a look at this. I want to explain how limits work. Okay, Windows zoom out more. Okay, so if you don't see what the graph looks like, I'll draw it over here. So pretty much, there is this, what we call, is you'll see that the graph is like this. The graph starts at a point, and this is how the graph looks like. It's going up, down, up, down, up, down, up, down, up, down, up. And we can see that as, when we say limit as t approaches infinity, this over here is your value of t. When we're saying infinity, it approaches infinity, we're saying the positive infinity. So this over here, like going to the right. So what we're saying is, what happens to the function? What happens to that function when we approach positive infinity? So when t approaches positive, so we're going forever. What's happening on the graph? Okay, well, we can see it's going all right, but it's getting smaller, as you can see. Its oscillations are getting smaller, and it approaches a value. It gets so close to a value, and it approaches. And we've just calculated that value. That value was 2,500 by using limits. And yeah, limits are very useful, actually. You just need to shove in the function over here, and it should just pull out the answer for you. All right, let's move on to the next question. Oh, yuck, probability. Mika is flipping a coin, the unbiased coin. So unbiased means it's fair, and has a probability of half landing on heads and landing on tails. Let x be the binary random variable representing the number of times that the coin lands on heads. Mika flips the coin 5 times, so n equals 5. Probability of x is what? So it's only 1 mark, so I'm just going to go on my CAS calculator, Control N, delete everything, and let's make a new. So what I'm going to do is I'm going to go on actual probability distributions and binomial PDF. The number of trials are 5, the probability of success is 0.5, and our value of x is 5, which gives us 0.03. So we just write the answer, 0.03125. There is no decimal place, so you have to give the full answer. The next one is the probability that it's greater than 2. So what we use probability distribution, not binomial PDF, but CDF now. And the number of trials there is 5. The probability of success, again, is 0.5. And the lower bound is 2. And the upper bound, the most maximum, is 5. And it gives us 0.81. So 0.8125. Next one. The probability that x is greater than 2, given that x is less than... Okay, I'm just going to change this because it's too much. We have to show some working out. I'm just going to say that the probability that x... This can be rewritten as this, by the way. Intersection s is less than 5 all over the probability of x is less than 5. Okay, what can we know? I'm just going to draw a nice timeline over here. Okay, so let's say this is 2 and this is 5. And we're saying that this over here, so when it's greater than 2 to infinity, it goes over here, and we're saying that it goes less than 5. It's useless when they're saying less than 5. We should just say over here, change that up to less or equal to 4. Less or equal to 4 over here. Less or equal to 4. So we're saying let's change that up to 4. So when do they intersect? Well, they intersect over here. So this can be rewritten as the probability of 2 between x between 4 all over the probability of x is less than 4, which would be equal to, let me use our CAS. So again, go on probability, go on distribution, go on binomial CDF. Number of trials, again, is 5. Probability of success is half. Lower bound, okay, let's do the top part. So 2 to 4. So we're going from 2 to 4. That's the first one. I'm going to copy that again. And then the next one is where we're saying the probability is less than 4. So this we can write 0. The lowest bound we can go is 0. Equals this. Now we just have to divide them. So this value over this value, we get 0.8. So to 3 decimal places, that'll be 0.806. Okay. Find the expected value and the standard deviation. To find the expected value, it's just NP, which N is 5, and it's half your p-value, so it's just 5 on 2. Your standard deviation, your SD is pretty much, it's only formula chart. I believe it's, if I'm not mistaken, what is it? Was it NP 1 minus P? Was it like that? It's on you, yeah. So which is 5 over 2 times 1 minus P, which is, well, it's half. Which is root 5 over 2. Yeah, so 5 times 2. Root 5 over 2, yeah. Hope that's right. Okay, those are your answers for that. Move on to the next question. The highest reached by each of the Mika's coin flips is given by the continuous random variable h with the probability function of this. Okay, there's unknowns. Where h is the vertical height reached by the coin flip. Wait, where h is the vertical height reached. So what she's doing is, if I'm going to draw a diagram over here. So this is Mika, and she's throwing this coin. So the coin goes over here. So it's that vertical height. So the vertical height reached by the coin flip in meters, where the coin and the floor. Okay, so from here, so she's throwing it. So this is where we're measuring it, from here to here. This. So from the floor. So the value of the indefinite integral, this. Well, 1 to 3. 1 to 3. That's 1. That's your answer. I mean, it's just equal to 1. How? Are they trying to trick people here? Because it's like, oh my god, like, yeah, if it's like a parabola, which you just say was a positive in this value, so let's say, I don't know, negative parabola from 1.5 to 3, it's over here, it's just equal to 1, yeah. That's your lowest bound is 1.5 and your upper bound is 3, yeah, it just equals to 1, that's what. Okay, let's look at the next one. Given the probability of H is less or equal to 2, find the probability of H, and the probability of H is greater than 2.5. Okay, and that. Find the values of A, B, and C. Okay, 3 marks. Under research I'm working out. So, what I'm going to do is, I'm going to try to solve, because we're trying to find A, B, and C, 3 stuff. I'm going to say, what can I say? Well, I can say that the integral from 1.5, because that's our lowest, to 2 of f of h with the respect of dh is equal to 0.35. That's your first equation. And we also know that 2.5 till your maximum is 3 of f of h dh equals 0.25. That's your second. What else? We need more. Okay. What can we do? F of h. Wait, when the hundred quotes of coin, what else can we do? Because we need like 3 equations to get this. To get 3 values where h of is vertical are reached by the height. Okay. Well, can we say... they've given us this. Oh my god, this. Can we just use that? And we know it's equal to 1, so we can maybe use that also. I'm just going to make this smaller. Make this smaller. And we can say that it's... Okay. 1.5 till 3 of h dh equals 1. That's your third equation. Using your calculator, that gives us... Okay, calculator. So, f of h. So I'm going to define... So first define f of h, which is equal to a times h squared. Oh, why is it capitals? H. Why is it capitals? Wow. Wait, control caps. Okay. Times. Okay, h squared. So h squared plus b times h plus c. Okay, let's put menu, algebra, solve systems of equations. We have 3 equations and we want to solve for A, B, and C. Okay, so the first one is the integral from 1.5 till 2 of f of h is equal to 0.35. Okay, the next one is 2.5 to 3 f of h dh equals 0.25. The next one is 1.5 3 f of h dh equals 1. Okay, that's good. They give us the values. Okay, perfect. So A is equal to negative 4 on 5, B is equal to 17 over 5, and C is equal to negative 167 over 60. That's that. The ceiling of Mika's room is 3. Okay, I straight away draw a diagram because I have no idea what's happening over here. They're just too much words, make me confused. So, the ceiling, so let's say this is your ceiling, Mika's ceiling. So this is Mika's ceiling. The ceiling of Mika's room is 3 meters above the floor. Say this is the floor, so it's just from here to here. From here to here, it's 3 meters. The minimum distance between the coin, and the ceiling. So the coin, so we're saying from here to, let's say here, that's where the coin is. Let's say that's where the coin is. So the minimum distance between the coin and the ceiling is a continuous random variable d with the probability density function g. The function g is a transformation of function f, which was this one over here, f given by g d, okay, where d is the minimum distance between the coin and ceilings, r and s are real constant. Find the values of r and s. Okay, so how can I do this? Okay, g on d, so let me just rewrite that here. G d f r d plus s. So the d here, so the d's are different, by the way. So this g on d, this d, we'll call it d1. And this over here, this d, which is d2, plus s. That d2, so what's the difference between those is, think of them like this. So this over here one, the d1, is pretty much, we're saying it's from the ceiling. So from here, this is where the coin is. This is where the coin is. So that's d1. That's the distance d1. And FRD, so this one, RD2, so the D2 over here, that distance is pretty much is when, what's her name? Mika, it's pretty much throwing it above the floor. So say this is Mika, and so this the coin, this is where D2 is. D2 is here. And what's happened is that there's been a transformation with D2 to make D1. And what is that transformation? Okay. Well, how do we even get to D1 first? Wait, to get to D1, this D1, well, D1 is equal to 3 minus D2. Yeah? Ah, okay. Okay, perfectly. That's there. So D1 is actually equal to 3D. So you know how, okay, that's easy. So we can pretty much equate RD2 plus S equal to 3 minus D2, which, which should give us, so your S value is 3 and your R value is -1. Is that right? So S equals 3, R -1. Yeah, I think that is. Because it's just being a transformation. We've just... Yeah. Looks right. Hope it is. Looks right. Okay. I'm going to move on to the next question. Mika's sister's Bella has a coin. On each flip, Bella's coin has a probability of P landing. So P of landing on heads and P on landing on tails, where P is a constant value between 0 to 1. Bella flips her coin 25 times in order to estimate P. Let P hat be the random variable representing the portion of times that Bella coin lands on heads in her sample. Is the random variable P hat discrete or continuous? It's discrete. It's a coin flip. A coin flip is... there can only be heads or tail. Like, it can only be like one head or two tails or three tails. So it's like a whole number. It's countable. It's like you can count them. So, yeah, it's discrete. We say it's discrete. Is the randomly discrete? We have to justify our answer. To justify it, we can say that the number of heads or tails, you can say the number of heads or tails are integers. They are full numbers, are whole numbers, or integers. And they can be countable. And they can be countable. Okay, countable. Yeah, that should give you 1 mark, yeah. So continuous, the difference between discrete and continuous. Discrete is like things that can pretty much count. Continuous is things that fluctuates, like your weight, your height. Like when we say your height is like 150.2 centimeters or something, it's, you know how you have that 0.2? It's like a decimal. If it has a decimal, normally it's always continuous. When it has a discrete, yeah, it's always discrete. When it has a whole number, it's discrete. So let's look at the next question. If if p hat is 0.5, find the approximate 95 confidence interval for p. Okay, I'm just gonna, it's 1 mark, I'm gonna do on calculator. So what I'm gonna do is go on probability, distributions, go on statistics, confidence intervals, go on 1 prob z intervals, and so what's 0.4? So before we even go into that, what's 0.4, which is 4 on 10, times your n value, your like number of flips she's done, 25, which is equal to, so this 2 folds in that 5, so and that's 2, so 10. So okay, we get 10. So what we mean, so we can say that p is equal to 10. So that's the number of success. We can write on our calculator as 10, number of values of 25. Okay, and we get, let me just drop that out. We get a confidence interval from, so 3 decimal places. So that'll be 0.208 till 0.592. Okay, that's good. Bella knows that she can decrease the width of the 95% confidence interval by using a larger sample of coin flips. If p hat is 0.4, how many coin flips would be acquired to half the width of the constant? Okay, to do that, let me just draw a diagram. So this is, think of this as, okay, so I'm just thinking, okay, let me just nicely draw this again. Okay, so this point to this point, say we're confidence interval. Our confidence interval at these points. Now, what's the confidence? I think so. The formula is normally it's p hat minus z over p hat or something, n minus 1 p, blah 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 over n or something like that. It's on your formula sheet, something like that. So the mean is here. So your actual mean is here. Your p hat's mean. Your mean is pretty much over here, the middle value. And your width is this value here, from here to over here. And we want to half it. So if we're going to half it, it's going to be like over here to over here. So what are those values? Okay. We can say that p value is this p hat minus, normally it's minus this. So what we're doing is, normally we're minusing this over here, and then we normally always plus, and we also plus, which is also this part over here. What about if, because your margin, so we call this a margin of error. So doesn't that mean that if we half it, we don't half this value, but we only half this margin of error, this value over here, because now we changed. We was originally like this, but now we halved it. We halved it, so now it's over here. So we've halved it, so over here. Okay, so what does that mean? That means that your margin of error, so we just need the formula here, so which is, I believe, I don't know, z, it's something like p hat, and I don't know, 1 minus p or something over n. So we call this margin of error. So if we're going to half it, it means half z p hat and n 1 minus p or something over n. We can bring that half inside. So if we bring that half inside, it'll be z p hat n 1 minus p hat over, if we bring it inside, it's going to be 4n. So how many coin flips would be required to halve the width? It'll be 4n, so it'll be 4 times the value of n. Okay, yeah, so 4 times the value n. So originally our value of n is 25, so n should equal 100. N times, yeah, is that right? Okay, confidence interval based on large. Okay, hope that's right. Okay, next question. Consider the function where f of x is, okay, you have f of x is this law. Okay, state the range. Okay, because this is our domain and we know these are our asymptotes, our range is, well, it's going to infinity from both sides, so all reals is our range for this one. That was not bad. Next question, find f dash of 0. It's 2 marks, so first I'm going to just find f dash of x. So I'm going to define that function, so I'm going to delete this, control N this, add calculator, and we are saying, okay, define f of x where it's equal to the natural log, so NLN, we can say x plus 0.5 half minus ln 0.5 minus x. Okay, so find the derivative, so dx of f of x, x gives us this. So we can say it's 2 over 2x plus 1 minus 2x minus 1. Therefore, f dash on 0 would be, take this value over here, let equals 0, which gives us 4. Next one, state the maximal domain over which f is strictly increasing. Okay, let's look at this. Well, it's strictly increasing everywhere. So we can see it's positive, positive. It has a positive gradient everywhere. So it's strictly increasing, yeah, the same domain as this. So it's just negative half to half. Hope that's right. Negative half to half. Where state the maximal domain for which f is strictly increasing. Hope that's right. So show that f of x plus f. Okay. Okay, let's look at what's f of x. So it's log e. So let me just write that. So it's log e. So just let me look. So it's log e x plus half minus log e half minus x plus log e. So this will become half minus x. If we put a negative, so negative log e, it'll be x plus half. Okay, yeah. So these, these cancel out, and also these cancel out. So it's equal to 0. Yep, I think that should give you the mark. Find the domain and the rule of f inverse of x. The inverse is what? Okay, and it's 3 marks, so we have to show some working out. First, I'm just going to find the domain. The domain is the range of actual f, the function f. So the domain, what's the range? Oh, we just, the range of f is all reals, so at least that's all reals. So to get that 3 marks, so to calculate inverse of f, the rule, we're going to say, okay, let f of x equal y. And we want to say interchange y and x, which would mean that go up. What's the function again? Okay, so we're changing. So it'll be okay. It'll be, just use a different color. So it'll be x natural. So log e y plus half minus log e half minus x. Okay. So, oh, sorry, that x is supposed to be a y here. What I'm going to do is, I know that I can rewrite this log e y plus 1 over 2 minus log e 1 minus 2y over 2. Is that right? Yep. And by using log laws, so log e, what's y plus 1 over 2 divided by times 2, 1 minus 2y. These cancel out, giving you x as log e, y plus 1, 1 minus 2y. We have that, so that'll be e of x, y plus 1, 1 minus 2y. Expand that, so it'll be ex minus 2exy, y plus 1. And bring that ex minus 1, y plus 2exy. So ex minus 1, take that y out, so it'll be 1 plus 2ex. So y is therefore ex minus 1 over 1 plus 2ex. All right, that's your rule. And that, oh my god, that's too much. Okay, that was a mess. So what I'm going to do is just, I'm going to first take this part here. I'm going to make it very small. Put it over here. This part over here. Okay. Oops, what's happening over here? Let me just take that. Okay. Take it small. Okay. Bring it over here. Now, your final answer is, now we just, because y is f of x, we measured, so we have to say f inverse of x is equal to ex minus 1 over 1 plus 2ex. There we go. If that's right. Okay, let h be the function. This, it's the same function, but there's a dilation of 1 over k, where k is element of OR, where k is greater than 0. The inverse function of h is defined by this. Okay. The area of the region is bound by the function of h, and h inverse can be expressed as a. Okay, so this is this area over here. Okay. The graph below shows the relevant. Okay, you are not required to find or define a of k. Determine the range of values of k. So values, so there must be more, such that a of k, so it means that area, this area, must be positive. So it must be greater than 0. It must be actual positive. So what I'm going to do for this one is, okay, I'm going to go back on my calculator. And so the best way to find the values of k, I think, for this question is by just sketching it. So h of x is just what? It's 1 over k just times the function, our function, original function, which was f of x, which was this. So if I can take this and go on this and put it over here and put a slider, make sure you put a slider, we get this. And we also know the inverse. I mean, it's right over here. So your inverse of h is given here. So we can sketch that inverse too. So we can say tab. Okay, so the inverse, it is ekx. So ek times x minus 1. 2 times kx times x plus 1. Okay. Okay, so we get this. So if we want the value, like the area to be positive, I mean, here we have nothing. I mean, where can we get like the area between those two? The inverse. There's no area. I mean, let's zoom in. Maybe there is, maybe there isn't. Let's zoom in. There isn't any. So, okay, what about if, okay, that's important to know. Let me just take my pointer. Okay, let me just take, oh yeah, okay. Oh, too many functions. So I'm just gonna put that over here. I'm gonna put that over here. Okay, can I take this? Okay, here, that's nicer. So when, okay, we must, okay. So if we put k in the negative values, I mean, it does give a actual, but, did they say k? But k is positive. Okay, k is greater than 0, I forgot. So k must be positive, so, and not equal to 0. So let's say 1 at first. There's nothing. There's no actual area that's bounded. 2, closer, closer, closer. Okay. What we can see is that when k is equal to 4, there's no area, but more than it, there starts to be area. What about if we put 6? Let's put 8. Okay. 9. Okay, so if we increase the value of k, we're getting a bigger area. So I think it was 4. That was, so 4. Yeah, 4 is just the point. Okay, so we can say values of k is k must be greater than 4, because if it cannot be equal to 4. I mean, there is no actual area. That's, so 4.1, 4.2 greater than 4, we actually start getting this area. Yeah, I think that's for that question. So set the value, is that right? Yep. Explain why the domain of a of k does not include all values of k. Well, didn't we just find out that more, like, you know how k is greater than 4? if k is equal to 4 or k is equal to 3, there is no area bounded. So there's actually no area bounded. So there's actually not even, area doesn't even exist. So can we just say for this one, there is when what can we say? When k is less or, when k is less or equal to 4, but that's not a right statement. So, because we got when we had, when k is between -4 to 4, so we can say when the values of k, so when k is 4, -4, the inverse of h, so wait, we're not inverse, just say h of x, we can, is that h, okay, the h of x and h of x, the inverse of when -4 to 4, the interval, so do not have area bounded. Do not have an area bounded. Is that right? So when -4 to k, the h of x and h of x do not have area bounded. Therefore, a of k does not exist. Hope that's right. I don't know. That's, yeah. I don't know how to explain that, but yeah, I think that's it for that one. Is this the last question? Wow, this is such... Okay, that's the last question. Okay, let's do this quick. Consider the composite function g of x, and it's this, where the function h of x is unknown, but differentiable function of all values of x. Use the following table. Okay, we can see that. So half, use the values, and f dash. Okay, find the value of g pi over 6. It's 1 mark. So g pi on 6. Okay, if we know that g of x, so g of x equals f sine 2 pi on 6, which is 2 times, so it'll be just pi on 3 in the middle. So it's just f sine pi on 3 is √3 on 2. So what's f √3 on 2? So f √3 on 2 is 3. 3 is your answer for that one. It's only 1 mark, so I'm just gonna rub this off. It's just rubbish over here, so yeah, I'm just gonna rub that out. It's not important. Okay. Next question. The derivative of g with respect to x is given by this. So this is the, okay, show that g pi over 6 is equal to 1. Okay, it just means that g, it's only 1 mark, so g, we need to show, but so g pi on 6 is 2, cos will become pi on 3. So what's cos pi on 3? It's half, so we can just put half here, times f dash. Okay, we know that sine 2x, so it was saying sine pi on 3, which is √3 on 2, which, what's f dash √3 on 2? 1 on 9. So 1 plus 1 on 9, which we get 10 on 9. Is that right? 10 on 9. I think that's that. What am I doing? Wait. What happened? Oh my god, why am I plussing it? Oh, we should just show it's 1 on 9. That's one because okay. So 2, okay. That's 1, so it's just this over here, which is 1 on 9. That's your answer, yeah. Find the equation of the tangent at this. Okay, so we know that x is pi on 6. We know that when g, we know the derivative of when pi of 6 is 1 on 9, so we know that m is 1 on 9. What about the y? Didn't we just calculate the y? Wait, when g of pi... Yes, which was 3. We just put them all together, so y minus 3 equals 1 on 9, x minus pi on 6. And I'm just going to use our calculator to calculate that. Just do it by hand. It's much quicker. So it'll be 1 on x minus 54 plus 3, y equals 1 on x. Okay, Let me just do this on calculator. So pi, okay, pi 54 plus 3. Oh. Okay, let me just, what's that? So, what's 54 times 3? 162. So, we're saying, what can we say here? Plus 162 minus pi over 54. Is that right? Okay, let me just solve it. Be safe. So, solve y minus 3 equals 109. X minus pi on 6, comma, y. Okay, yeah, I mean, we could have just left it as that, but yeah, we'll keep it. We won't even keep it. We'll keep it, yeah, just as that over here. Okay, we'll just keep it this. Okay, move on to the next question. And that's your last question. Okay, find the average value. Perfect. So find the average value of the derivative function g dash of x from this to that. Okay, so we're saying that 1 over pi on 6 minus pi on 8 from pi on 8 pi on 6 of g dash of x respect to dx. That's what we're trying to find. What's g dash of x? Well, g dash of x is here. G dash of x, okay. So, but g of x is here. Ah, okay, it's right over here. G of x, okay. So we don't need to calculate that. So yeah, we just need to say, so the integral of g dash of x is just that. Which we can just say, rub that out. We can say from, which was what? F sine 2x, so f sine 2x, f sine 2x from pi on 8, pi on 6. Okay, I'm just going to do this on calculator just to get the value. I don't want to mess this up. So we're saying that 1, okay, first pi on 6 minus pi on 8. Yep, and that is 24. So 24 pi. Okay, so 24 pi. So if we sub in, okay, pi on 6 first. So pi on 6, so what's sine pi on 3, which is root 3 over 2? What's f root 3 on 2, which is 3? So we can say 3 minus, so if you 2 times pi over 8, which is pi over 4, sine pi over 4, which is 1 over root 2. So 1 over root 2, which is the same as this. 1 over root 2 of, so that'll be 5. So 1 over root 2 will be 5. Will be 5. Oh, maybe that's right. Okay, so wait. Sine 2x. Root 2, so that will be equal to 3 minus, so negative 2, negative 48 over pi. That's your average value. Let me just write that as average value. I'm not too sure that's right, but yes. Sorry guys, my video just cut. So now we're gonna do question 4. Question E. Find 4 solutions to the equation g of x equals 0 for the interval from this to that. Okay. What's g dash of x? G dash of x. Okay, so it's 2 cos 2x. So 2 cos 2x times f dash, I think it was sine 2x. We want to let it equal to 0. Was that right? Okay. How would we do that? Well, okay, first our domain is from pi to 0. Because we're doing 2x, wouldn't it be 2x, 2 pi to 0? So we're doing actual full rotation. Okay, so what do we know? Well, we know that we can get two equations from this because they're being multiplied. We can say first one is 2 cos 2x equals 0. That's your first equation. We can find solutions for that. And also f dash sine 2x equals 0. That's your second equation. Let's do the first one. So the first one, 2 cos, so it's the same as saying cos 2x equals 0, so 2x. Okay, so if I draw a cosine graph, quick cosine, goes like that. We got pi on 2 and 3 pi on 2. So pi on 2, 3 pi on 2, x is pi on 4, 3 pi on 4. So that's for that one. The next one is, okay, f dash of, okay, to get rid of that f dash, we know that, so I know normally that if we have something like f inverse or f dash, let's say we had f dash. Is it f dash? Okay. So to get rid of that f dash, we need to integrate. So f dash of sine 2x equals 0. So if we integrate both sides, it'll be sine 2x equals, because that's a constant, so integrate that. We would say it was some constant. No, what would it be? What would it be? So normally it's a it would be some constant. I don't know, some value of c. So it's some value of c. But what's the answer? So sine 2x. Okay. Maybe go up here and let's have a look. All right. Wait. If so, wait. Okay. Okay. So from, we know that, wait, f dash of x is equal to 0 when the x value here was it. So f dash of x is equal to 0 when, so f dash is equal to when it's root 2 over 2, so which is just 1 over root 2. So maybe we can just say when it's 1 over root 2, it's equal to 0. So yeah, equate the inside of them. So it'll be sine 2x equals 1 over root 2, which is, if I'm not mistaken, 2x equals, so sine's positive CA, so here, S, so here. So we have pi on 4 and pi minus, so pi minus pi on 4, which is 3 pi on 4, which is, okay, x is equal to pi on 8, 3 pi on 8. These are your solutions, 4 solutions. Yeah, so these are your 4 solutions. I'm not too sure if they're right. Have I done that? I mean, it's the end. We finished the exam. Okay. I'm not too sure if they're right. Guys, I'm very tired. Yeah, this exam is very tiring. I hope you guys enjoyed this video. Please, I'm not very sure, by the way, for the last question. And if I have made any mistakes, please make sure to comment down below. So yeah, I can learn from them. I hope this video taught you something, how to, yeah. So I'm not very sure of question E, if that's right. Did I approach it right? Yeah, so guys, I hope you guys enjoyed this video. Make sure to like and subscribe and share it with your friends. And yeah, have a good day.